Hey everybody, Steven here. So I'm just gonna go over the 2018 Architectural Technology 1 exam. In this video, I'm just gonna cover section B, Environmental Systems, and especially question 6. So it's about sizing the downpipes and the gutters and calculating the area of water that's gonna go into those. Let's jump into Photoshop and just click on this one and red. So they ask us to calculate the plane area of roof section discharging to duct pipes A, B, and C. So the first thing we need to do is to locate where they are. So we got duct pipe A here. And that's pretty low. 60. And then duct pipe B and duct pipe C. So we need to know how much of the roof surface is going in there. So when they say roof surface, it's like when it's raining, the water will drop onto that roof, and then it will slide toward the gutter, and then the gutter will take the water to the downpipes. So what's important is to find out the type of roof it is and where the direction of the water. So by looking at the shape of the roof, you can tell this is a hip roof and this is a gable, and you have to pay close attention to the direction. So all the water that's hitting that surface here is going to slide toward this side, and same for all the planes. So for this one here, it's going to go this way, this one here this way, and this plane of the roof dropping that way, and this one going this way. So now that you know the directions of the water, you need to know the direction of the gutters. Gutters, as you can see, usually on the edge of the roof. So one here, one here, one there, here. Here there's no gutter because it's a gable roof, and one here. So here you also have some arrows, so we'll tell you direction. So this point is the highest point, so the water that will drop here will just go down this direction, so that's the lowest point. And usually on like long facade like here, you would have a midpoint. So from the, well, this is not the middle, but here you would have, that would be the highest point, and then the gutter will slowly go slope toward this downpipe, and from that point it will slope to this side. So which means that the area of this roof, like, so the water that's going to drop on that roof is divided along here. So that's important to know before we start our calculation. I'm just going to delete this, and we're going to start with downpipe A. Let's go with some red. So we're going to try to find out how much water is going to go in here. So you can see that this one, so you get this plane of the roof. When it falls here, we go into that gutter, and then we go to that pipe A. You don't take this side, because this side is going to fall to that pipe B. What else going there? So we have this plane of the roof, so everything that goes here will drop into that gutter, which then will go into that pipe. So the area that we need to calculate that will go in that pipe A as this surface there. Is this. So to calculate that, just gonna go to another layer on top. We need to first maybe calculate. Oops. Oh, because it's 6%. Need to calculate this area just to make us easier. Calculate that first, and then we're gonna calculate that little part there that's left over. So we know this is 7 meters, and because this is the middle of the roof, so this part here is actually 3 meters. So that surface is going to be 21. And now to calculate this little piece, what we do is we calculate that surface there. So we know this is 3 meters, and because it's 45 degrees, it's a square, so this is going to be 3 meters as well. So the total of that surface is going to be 9, but because we just want half of it, so it's going to be 4.5. And yep. So now the total amount, so we're just going to do dPA equals 21 plus 4.5. So now we get 25.5 square meter. So that's the amount. So that's the area of water that will go into that downpipe. Okay, now let's go to downpipe B. We're just going to change color, make it easier to read. And so it's going to go from this side here. And we also have that plane there that's following that direction. And I'm just going to fill those in. So that's the area of water that will go into downpipe B. And to calculate that, we're going to first calculate this first. So it's going to be 6 meters times 3. So we're going to have 18. And now we calculate this surface. So we know this is going to be 3 plus 5. So that distance is going to be 8. And we got 3 here. So it's going to be 24. So the total for downpipe B is going to be equal to 18 plus 24. And that's going to be 42 square meter. Make sure when you do those calculations to not overlap them. So, I mean, you could go calculate this one here and then the leftover. But yeah. And now we're gonna go to that part C. Let's pick another color. Green. Size. So now this is gonna be this plane here. And this plane here. So this is the area that's going to go into downpipe C. And how are we going to calculate this? What I'm going to do is, because earlier we calculated this is 4.5, so we know that this is going to be 4.5. Let me decrease the size. This is going to be 4.5. And we're going to calculate this one. And then we're going to calculate this one after. So here, to find that distance, we know this is 6 meters. So this one is going to be a square 3 by 3. And here we know it's 7 meters. We know this is 3. So this distance is 4. So we got 4 plus 3. So this distance equals 7. And then times 3, it's going to be 21. I'm just going to leave that here. And for this one is 3 meters times 5. So we get 15. So DPC is going to be 4.5 plus 21 plus 15. So DPC equals 4.5 plus 21 plus 15. And then we call Mr. Calculators. 40.5. So that's the area of water that will go into this downpipe in case of raining. So now we got those values. They ask us to downpipe size as calculated. So downpipe size, it's this table, and here's what they ask us. So there's different values depending on the roof pitch. So we need to find what's our roof pitch. So roof pitch is 46. So we need to work on this side here. And so we got 25, 42, and 40. 25. So we get 35 here. It's bigger than 25, so it's okay. We can use 63. So for DPA, we can have a 63 mm diameters. And for DPB and TBC, 42, we have 50 here, so we can use 74 millimeter diameter for B and C because they're both below 50. So 74 mm diameters. Okay, so what's next? Cross-sectional area of gutter required. Okay, let's turn that off. So now what's the difference is we need to locate the gutters. So for downpipe A, it has 2 gutters. There's one here. Let's go multiply. And there's another one here. So we can call them, let's say, gutter 1 and gutter 2. So downpipe A, gutter 1, and gutter 2. So the area going into that gutter is only this part here, because on this side is going into gutter 2. So to calculate this, earlier we did that calculation that this side is 4.5, so this is symmetrical on the other side. So this area is going to be 9 square meters. So it's going to be 9 square meters. And on this one, it's going to be this area there. So what you could do is to calculate the whole thing. So it's going to be 7 times 3, so it's going to be 21. But then because we need to remove that part, so it's going to be 21 minus 4.5 equals, help me, 16.5. Or you could have just calculated this part here, so it'd be I think we did 4 earlier, so it's going to be 4 times 3, so it's going to be 12. 12 plus 4.5, so it could have been 12 plus 4.5, and then you would have the same result, 16.5 square meters. So it's just different way of calculating. And just gonna change color, blue. So for delta B, you would have this gutter here. We have this gutter here, and we're gonna call it gutter 1, and this one gutter 2. The surface that's going to gutter 1 is just this one, and if you calculate that, so it's 6 meters. We're going to divide in half, so it's going to be 3, and this is 6 meters divided in half, so it's going to be 3. So this is going to be 9 square meters. dpb, that's going to be 9 square meters plus this little part, so we know it's 4.5. So it's going to be 13.5 square meters. And G2, it's going to be surface there, so which is distance, and we know that's 3 meters because of here. It's 5, so it's going to be 8 times 3. That's going to be 24 and 4.5 because it's that surface. Oops. 24 plus 4.5, and then we get 28.5 square meter. Let's go DPC. So we have this gutter here and this one. So what I'm going to calculate is this one first. Easier. I'm going to calculate this area depth first. So it's going to be 5 times 3. So it's going to be 15 plus 4.5. And I forgot to name them. So this is going to be gutter 1, gutter 2. So DPC gutter 1 equals 15 plus 4.5, so we got 19.5. And G2 would be calculating this surface, so we know it's going to be 4 times 3. G2 equal 12, and then plus get 4.5 here, and we get 4.5 there. So 4.5 plus 4.5 equals 9, and so we got 21 square meter. So I'm just gonna go over here, and so this is the one that was 21 square meter that we just calculated, and this one that was the 19.5. Okay, so now we get a cross-sectional area, and now we need to find the No, actually, what we got is the plan of area of roof discharging to sections of gutter. So that's what we got. Those values are the one that's on that axis. And so what's been asked is cross-sectional area. So that's the one around here. We're just gonna zoom in and see what it is. This way. You can see there's 4 lines, and those lines are for different type of pitch. So you have to remember in our drawing they were saying 46, so the line that we need to look at is this one here. So this one here. Oops. That's this line. Okay. So now we got 9 square meter. So it's 100. So 100 actually our value are much lower. So if you go here, there will be 50 if you divide by 2, there will be 25. Divide by 2 again, there will be 12.5. So 9 square meter is all the way around here. And if we do a straight line, as you can see, it's not even touching that this line here, but because they said the minimum of the cross-sectional area needs to be 4,000 square millimeters. So for this one, it's going to be 4,000 square millimeters. And our 16.5, I guess it would be a little bit above from here. And yeah, so it's a little bit, it's still below the 5,000 because the 5,000 line is here. So we'll still go with the minimum. So it's going to be 4,000 millimeter square. Let's just erase that. And I'm going to pick blue. So now for downpipe B, we got 13.5. So same is going to be around here. And it will be below the 4,000. Below the here, so the minimum is going to be 4,000 millimeters square. And now we got 28. So 28, I think it's going to be around here. If we do the straight line, it's going to hit around that point. So if we go down, so it's 5,000, 10,000. So it's like every 1,000. So it's 5, 6, 7, 8, 9, 10. So this is 6,000. The cross section is going to be 6,000 millimeters square. And now if we go, just going to delete that again. And I'm going to pick up a green. So we get 19.5. So it's around, I guess, so if it's 25, a little bit below. Yeah, so it's below that 5,000. So it's going to be 4,000 millimeters square, because that's the minimum requirement. And then we got 21. 21 will be a bit above. And I think this one touched the 5,000. So like if it meets here, go down. 5,000 millimeters square. So, okay. But remember, when you do this, you really have to be careful which line you pick. So the roof pitch is really important because you might have a 25. So if you had 25, the value will be totally different. Okay, and now what do we need to do? Suggest a suitable gutter size for the building. So usually when you pick a gutter size, you pick for the largest area. So in our case, we got 4,000, 6,000, 5,000. So it just makes sense to pick 6,000 so it fits everywhere. And gutter size comes in different sizes, but the generic profile will be something like this. So you'd have the height, the width, and then something like that. So you would have your fascia here, your rafters, and then you would have the roof cladding. So what they're asking you is what's the height of that gutter? And for the sake of this, we're gonna imagine this is gonna be 100, and to reach 6,000, we need a gutter height of 60. And that's because when you calculate the cross-sectional area, which is going to be 60 times 100, so this thing here, you're going to get 6,000 millimeters square. And yeah, because of the angle, of course, it'll be a bit more, but so that's the minimum that's required for this question. I think that's it for this part. If you have any questions, just let me know in the comments, and I'll try to get back to you as soon as possible. Thank you.